Hello, I'm Dr. Charles Severance, and this is my little miniature lecture on least common denominators the easy way. So there's a couple pictures of me. There's the kind of respectable professor picture and the tough motorcycle guy on the right. Both those people, actually. So the first thing to wonder when we talk about least common denominators is really like, who cares? Why are we even talking about these things? Why does everybody make such a fuss about least common denominators? And I'm going to skip that for now. You're just stuck with least common denominators for now. At the end, I'll come back and talk a little bit why our math system really obsesses with least common denominators. So you're faced with a problem that you have a fraction. Usually it's either addition or subtraction. You need them for addition or subtraction of fractions, where you need to find the least common denominator. So what really is the problem? You're presented with a 1/5 plus 3/5, and what they're really asking you to do is find the number that belongs here, the lowest possible number that will make for a successful addition. So before we dig into that, let's review a bit of terminology. These numbers on the top, all these numbers on the top are the numerators. Numerator means thing on the top. Denominator means thing on the bottom. And so we have the numerators and the denominators. And so that's terminology you just have to know. Why didn't we call them thing on top, thing on bottom? I don't know, probably Latin or something like that. So our easy fraction addition problem, our job is to come up with these numbers. But the number we've got to come up with first is this number. We've got to come up with what the denominator is. So the first thing to do when you're faced with this kind of a fraction problem is look at the denominators. Check to see if the denominators match. Right? If the denominators match, that means that it's a real easy problem because they have actually already gave us the least common denominator. And if they match, the least common denominator is the denominator that they both have. So here we go, least common denominator 5. The first step is to figure out what that least common denominator is. So we have 5 because they match. That's the easy. So now you know what that number is, and now it's numerator time, and so we got to figure out what the numerator is. And of course, if you have the same denominator, 5, we don't have to do anything except simply add across. Add the 1 plus the 3, and that gives us a 4. Okay? And as long as the denominators are the same, the denominator of the sum is the same as the denominators, and you just add or subtract across the top, and it just produces that top number. So 4/5 is our answer. So in easy situation, step 1, look at the two denominators. Sweet, they match. So then we put a 5 here, and then now that we have everything matching here, we simply do our addition across the top, add the 1 plus the 3, and that gives us 4, and our answer, of course, is now 4/5. Okay, so that was easy, and I'm betting that you actually already knew that before you even came to this least common denominator thing, because that's the easy least common denominator. That's not what they give you. Usually what they do is they're going to give you a hard problem. They're going to take this perfectly easy problem, and then they're going to turn that into a diabolically hard problem by changing it so they're not the same number. So now it's a little more challenging. We have got to come up with a common denominator. That is, again, we have got to figure out what this number is. What is that number going to be? So we can't they're not the same anymore. 4 and 5 are not the same numbers. So we got to come up with something else. So how do we come up with a number? And basically what we're doing is turning it so that these bottom numbers are the same, just like in the previous problem. We've got to transform each of these fractions a little bit. Got to transform them so that all the numbers on the bottom are the same. So that what number should we try to make all the bottom numbers be? So again, there's a quick and dirty answer. If you really just want to do the addition, you don't have to find the least common denominator. We can find the not least common denominator. We can find just the common denominator. So it's real simple. We just multiply the two numbers together. So we multiply them. 4 times 5, and that gives us 20. So that says that a number that will be a suitable denominator all the way across the bottom to make them all equivalent to will be 20. So we just multiply the two denominators together to produce the not least common denominator. Maybe not least. This one turns out to be least common denominator, but it's not guaranteed to be least. So now that we have figured out what our least common denominator is, we need to transform these two fractions. Right? We've got to transform 1/4, and we have to transform 3/5, so that the 20 is here and the 20 is here as well. So what are we going to do to these two fractions to make it so 20 is both places? Okay, so what you should do is you should kind of visualize the notion that these fractions, we are going to do something to the fractions in a way that gives us equivalent fractions, except that 20 will be in the denominator. So we're going to draw some green boxes around these fractions so that we keep track in our mind that we're not really changing these fractions, we're just multiplying them, we're applying something. So what's going to happen is we have got to figure out a number that we're going to multiply. One fraction, another fraction. 1/4, 3/5. There's still going to be 3/5, but we're going to express 3/5 in a way where 20 is in the denominator. So we somehow got to redo this so that 20 is in the denominator. Okay, so the question is, what can we multiply by the 3/5 fraction so that 20 is in the denominator? What can we multiply by the 1/4 fraction so that 20 is in the denominator? Now, let's review a quick fraction fact. Any number over itself, 2/2, 3/3, 4/4, 27/27, 1,004,268, blah, over 1,004,262. As long as these two numbers are the same, those are equal to 1. So that's just a multiplication fact. As long as the top number and the bottom number are the same, then it equals 1. So we can go back to our little problem where what can we multiply the top and the bottom by? And as long as we match the top and the bottom, then it's the same as multiplying this by 1, which means we're not really changing the fraction in the green box. We're just changing how we are representing the fraction in the green box. And so the question is, what do we multiply 5 by to get 20? The answer there is 4. 4 times 5 equals 20. And we can ask ourselves the next question. Here, let's go on to the next slide here. So now we have to figure out what we're going to multiply. 4 times 5 is 20. And so we got to put 4 in the top. And over here, 5 times 4 gives us 20. So we have to put 5 in the top. Now with multiplication, it's actually multiplying fractions actually much easier. You multiply the tops and you multiply the bottoms. You multiply the tops and multiply the bottoms. The bottom in this case is going to be 20. So you multiply the tops, you multiply the bottoms. Multiply the tops, multiply the bottoms. So here, multiplying this is going to give us 20. Multiply this, it's going to give us 5. 4 times 3 is 12. 4 times 5 is 20. So now what we've got is conveniently, we have all 20s in the bottom, which is exactly what we've done. And we've transformed 1/4 and 3/5 into 5/20 and 12/20 respectively. Okay? And so remember that our green box, just give me a green pen, our green box was the original 3/5 fraction. This green box was the original 1/4 fraction. And now that we've done this multiplication, we end up with those same. So this is 1/4 and this is 3/5, but now they're transformed, so 20s are all on the bottom. Now, so it works out that we start with 1/4 plus 3/5, and we multiplied these two numbers together, 4 times 5 to get 20, and then we have to do something back to the fraction so that the bottoms are 20. So we multiplied the top and the bottom of this by 4, 4/4, and so we get that 3 times 4, oh, let's change colors here, 3 times 4 becomes 12. We multiply the bottom of this to get to 20 by 5, Multiply that by 5. 5 times 1 is 5. And again, our goal was to get so that the bottoms are all 20. So these are the same numbers. 1/4 and 5/20 is the same number. 3/5 and 12/20. It's just a different representation because we multiplied each one by the number 1. 4/4 in this case, and 5/5. So it's okay to multiply by 1 without changing the fractions. Wow, that's quite the mess over there. Boop. So the essence of this is we transform these numbers to get 20 in the bottom by figuring out some number to multiply equivalently to the top and the bottom. And now what we've done is we have transformed our difficult multiplication problem into an easy addition problem. Sorry, our hard addition problem has been transformed into an easy addition problem. So the rule is check the bottoms, they're the same, awesome. Then simply add these together. 5 plus 12 is 17. So we just add across the top, since the bottoms match, add across the top and get 17. And so the purpose of finding a common denominator is to turn a hard fraction problem into an easy fraction problem. And so by the time we get these 20s in the bottom all to match up, then this is now an easy fractional addition. 5 plus 12 is 17. Okay, but you know what? If you're listening carefully and you know a little bit about least common denominators, you will realize that I never even mentioned anything about least common denominators. And I carefully did that. That's a common denominator. By multiplying the two bottom numbers, you get a common denominator. So the problem with a common denominator, well, a least common denominator is the lowest possible common denominator. So here's another hard problem. 3/4 plus 1/6. And as usual, our first goal is to figure out what this number is going to be, right? And again, we're not going to do the least yet, but we're going to think about least. First, we're going to start with any, and then we'll work towards the least common denominator. So the any rule is you just multiply the two numbers together and get to 24. 4 times 6, 24. Okay? Then, just like we did before, once we have determined that the common denominator is 24, then we have to transform these numbers here so that they're the same. And in this one, we'll multiply top and bottom times 6. And here we'll multiply top and bottom times 4. Now the interesting thing that you're probably noticing is that it's really easy because this number is that number. And this 6 is what we multiply by. So 4 times 1 is 4. 3 times 6 is 18. And so now we have all the bottom numbers the same. We've transformed the top numbers so that these are equivalent. 18/24. 18/24 is the same fraction as 3/4. And 1/6 and 4/24 are the same thing. We just multiplied. We multiplied by 6/6, 4/4, which is the number 1, because any number over itself is 1. Okay, so we've got all the numbers the same, and now we just add the numbers together. So that ends up being 22. Okay, so 18 plus 4 is 22. So we have 22/24. Now, if you know anything about fractions and you're looking at 22 and 20/24, something should be like, something's not quite right with this picture. Something doesn't look quite right. There's something wrong with that fraction. It's not the wrong answer. It's not the wrong answer. It is the answer, and it is correct, but I'll just let you think for a while. It's the right answer, but there's something wrong with it. You're supposed to start seeing this after a while. What's wrong with it? It's supposed to like just kind of creep out at you. So here's what's wrong. So 22/24, what you're supposed to sort of visually see in your head as you sort of stare at this is you realize that that top number and the bottom number are actually themselves a product. So 22 is really 11 times 2. 24 is 12 times 2, right? So you're supposed to somehow decompose this number. See, 22, now the fact that both of them are even makes this a little tricky, easier. So you say, oh, there's got to be a 2 in both of them, right? So 11 times 2 and 12 times 2. Now, just like when we multiplied, 2 over 2 is equal to 1. And so we can eliminate the 2 over 2. We can cancel it out. Okay, so you're supposed to see this, and then you're supposed to cancel it out. You're removing the value 1. And in a multiplication, anything times 1 is still itself. And the reduced form of this fraction is 11 over 2. So you're supposed to visually sort of see this happen, imagine it, and then realize there's an extra factor in here, this 2. Take it out, and then this ends up being the reduced form. Reduced form. And that's better. It's not like this was wrong. This was okay, but this one is better. That one's better, okay? So we don't like, it's sort of thought of as tacky. Tacky. You know, you're showing that you don't have the best game if you leave your fraction look like this. But if you change it so that it's in reduced form, then you're like showing how cool you really are. So if we then sort of take a look at this whole process, we start with a situation where we have numbers that don't match. We multiply them together to get 24. Now we've got to get to the point where these numbers have 24. And so we multiply this by 4 over 4, and this by 6 over 6. And then, let's get a different color. This becomes 24. This becomes 24, which was our desired goal. And then 1 times 4 is 4. 6 times 3 is 18. We add across, and then 18 plus 4 is 22. And then you realize that is not in reduced form, so you pull out a 2, and you get the reduced form, which is the proper answer, 11 over 12. Now, we really didn't do least common denominator in any of this. We found a common denominator, but we didn't do least common denominator. So basically, we ended up with a reduced fraction in lowest terms. Okay? That's what this is. It's a lowest term reduced fraction. It's exactly what you're supposed to get. You're not supposed to leave your answer with that extra factor of 2 sitting in there. You're supposed to see it. Again, even numbers are the easy ones to see because you can pull a factor of 2 out. Okay, so it's reduced to its lowest terms. So there we go. Okay, so it is now time to do least. Time to go. Time to get with the least common denominator. So what is least common denominator? Where does it fit in this whole picture of a common denominator and then removing redundant extra terms and getting it in lowest terms? Well, the simplest way to express it is that if you were to sort of ignore all the other things, all these little steps in the middle, we don't need these. You know, let's just ignore all this stuff. Just ignore that. And is it possible to come up with that lowest common denominator before we start the calculation? And we can, at the end of the day, we can save ourselves this extremely time-consuming step of reducing to lowest terms. We could perform the addition and end up with the fraction over 12 rather than over 24. So we don't have to do this step. It's not about 12 and 24. It's this sort of extra step. We're going to get rid of that step, right? And so if we can come up with that final denominator, this denominator right here, if we can come up before we do the addition and just use 12 instead of 24 for our thing. And so you think, well, that's going to save ourselves some time. But we have to come up with a way to know what this least common denominator is. Okay? So the question is, what is the least common denominator so we can skip this last final step over here? Okay? So if someone somehow gave us that least common denominator, if we knew in advance, we could save ourselves some time. Okay? It's the lowest possible common denominator. And let's call that thing the least common denominator. Okay, so let's just for the moment assume that we were handed the least common denominator. Somebody gave us the least common denominator. How would we do the calculation? Well, again, what we're trying to do is take the original numbers, 3/4 and 1/6, multiply them by the same thing on top and bottom again, so that the bottom, once again, is 12. So we want the bottom of this to be 12 and the bottom of that to be 12. So that the bottom of all of them. So the question is, what do we multiply? What do we multiply? Right? So let's go ahead and do this one. So the first thing we look at is here and here. What do we multiply by 4 to get to 12? And that would be a 3. What do we multiply by 6 to get to 12? That would be a 2. And then we have to put the same thing at the top. 2 goes up there, and 3 goes up there. Okay? So we have figured this out first, and then that just copy. Figured that out, and then that. Somebody told us what the least common denominator was. We are very thankful for that. So now we know what to multiply. We're going to multiply the 3/4 by 3/3, and we're going to multiply 1/6 by 2/2. So we multiply the 3 times 4, that becomes the 12. 2 times 6 conveniently becomes 12. And look at that, we've got all 12s in the bottom. So now if we look at the top, 3 times 3 becomes 9. 2 times 1 becomes 2. And so now we have once again transformed a difficult problem into an easy problem. And now all we've got to do is add across the top, because the denominator is the same. 9 plus 2 is 11. And so this is the final answer. There's no more factors to remove. So there is no step here. There's no step here. It's not this. We figured out what this number was. We used it throughout the problem. And when we're done, we're done. We're all done. Finished. So somebody gave us this 12. And so we saved ourselves some time, and we got our fraction in its lowest terms form. Okay? So again, just to sort of summarize this, we ask, what do we multiply the 6? That's a 2. What do we multiply by the 4 to get 12? That's a 3. We put that in the top. We put the 2 in the top. 3 times 3 and 2 times 1 becomes 9, and 2 times 1 becomes 2. And the bottoms are all 12, and we add these two things together, and it's 11, and we're all done. Okay? So that is sort of the quick way. That's it, if we know what the least common denominator is. And now we get to the reason for this. Everything up to now has been a review, and now we get to why we started this in the first place. If someone could just give us the least common denominator, it'd be easy. But our job is to find it. That's our problem. If we didn't need the least common denominator, we just multiply the two numbers together. So, it is time. There are two ways to find the least common denominator. There's the way that you're taught in school. That's the hard way. And I'll even show you the hard way. The hard way is you take each denominator and reduce it to its prime factors. What's a prime number, you say? Oh, sorry. That's one of the problems with the hard ways. You got to remember what prime numbers are. And you got to know how to reduce a number to its prime factors. Then you construct the least common denominator by moving from left to right and bringing across each of the prime factors. And when you go from one fraction to the other, you only include each prime factor once. Okay? Then, once you have all the prime factors together, you multiply them together to form the least common denominator. Now, that's cool. This is important stuff to know, and I want you to know what prime numbers are. Prime factors. It'd be nice to be able to, visually be able to reduce a denominator to its prime factors. That's fine. But if you're having trouble to finding least common denominators, perhaps you should use a little crutch to start, and then later you can learn the hard way. So perhaps what we'll do instead is we'll just simply cheat, because that's the second way to find the least common denominator, is to cheat. Okay? It's hardly cheating, but we'll get there. So, Before I tell you the easy way, I'll quickly describe the hard way, and then we'll show you the cheating or easy way. So again, our problem is simple. We have two denominators that are not the same, 4 and 6. What is the lowest common denominator? 24 is a common denominator by simply multiplying 4 times 6, but that in this case is not the least common denominator. We happen to know from the previous problem that 12 is the least common denominator, but that's cheating, that's peeking, so we're not going to look, so forget that. Forget I ever said that. Okay, so there we go. So 24 is not. So this is how you do it if you're going to do it the right way. So you're supposed to decompose each of these into their corresponding prime factors. There's a series of numbers that can be multiplied together to produce these numbers. Okay, that's the prime factors. And so at some point you're supposed to stare at this until you see that 4 is really 2 times 2. You're sort of dividing, you're sort of breaking it down. It's really, these are the prime factors. 2 and 2 are prime numbers. 6, as you see it, breaks down to 2 times 3. So 2 times 3, 2 and 3 are prime numbers. So you're somehow supposed to see this. You're supposed to see 4, but instead you're supposed to blur your eyes and see 2 times 2. You're supposed to see 6 and see 2 times 3. So these are the prime factors. So it's the same number, 1 over 2 times 3 over 2 times 2 is 3/4. 1 over 2 times 3 is 1/6. So these are the same numbers, right? 3/4 and this are the same number. This and this are the same number. But we've reduced it. We've sort of we've exploded this 6 into its little baby parts. Okay? So now what we do, once we know what the prime factors are, we are going to add them to our least common denominator. Oops, this is not supposed to be there. Pretend that 12 is not there. So here's what you do. Pretend the 12 is not there. 12 is not there. Typographic error. Blank. Okay, so you go for first fraction. You say, okay, 2 and 2. I've got to put those over here. 2 and 2. Then I go to the second fraction. And now I say, oh, I need a 2, but I've already got a 2. So I don't have to put that one in again. I need a 3. I don't have one, so I add a 3. So what I end up with is this factor, and this factor in the common denominator, but not this factor because it's repeated back here. So we're removing repeated factors from the second fraction. Okay, we need both of these 2's, but we don't need this 2 once we've already had a 2. Okay, so then we can just multiply these numbers together. 2 times 3 is 12, right? So 2 times 3 is 12. And again, just to summarize, this one made it in, this one made it in, this one did not make it in, and the 3 did make it in. Okay, and so this was that rule of don't add a factor again. Okay, so that one didn't make it in. Okay, and so now we've got each factor in once. There's the 2 and the 3 for the 6. There's the 2 and the 4, but we've not doubled that 2. So then you multiply those together and you get 12 as the least common denominator. So this, adding each factor once for each fraction, is the way you get straight to the least common denominator. But that's a little tough. That's a little tough. Okay? So that is the official way to do it. And now I'm going to teach you the easy way. So here's the easy way. So, and by the way, this isn't a perfect way, but it's going to work in most problems that you're going to see. So watch me go here. So the first thing I do is I just multiply the denominators together to get a common denominator, not the least common denominator. Then you divide that common denominator by 2, 3, 4, and 5, and you might have a little more than that. And then check to see that that common denominator, if it's divided by 2, is still a common denominator by seeing if something can be multiplied by these numbers. And then pick the lowest of the common denominators that you find. So these are all the number and the number divided by 2 and the number divided by 3 and the number divided by 4 and the number divided by 5, are potential least common denominators. And we got to pick the one that ends up the lowest. It's probably easy. if I just show you. Okay, so here we go. So the first step is we need a common denominator, but may not be the least common denominator. So we just take the two numbers, multiply them together, and we say 24 is a common denominator. It might actually be the least. So what we'll do is we'll put 24 up, and remember 24 is a possible least common denominator. So that's our possible least common denominator. Might not be least, but we'll check. Okay, so then the next step is to take this number, divide it by 2, and then check to see if this is a good common denominator still. Well, the way you check that is you ask yourself, is there a number that 4 times something, it's not the same number, 4 times one number equals 12, and 6 times another number equals 12. So we're checking to see if this is a good common denominator. There we are. So is there a number that we can 4 times something equals 12 and 6 times something else equals 12? Okay. And the answer, of course, is yes. 4 times 3 is 12 and 6 times 2 is 12. So that means this is a common denominator because it's a whole number. 4 times this 4 times a whole number equals 12. This 6 times that whole number is 12. So 12 is a common denominator. So we will add that to our list of possible least common denominators, and it's lower than 24, so we're going to like that, okay? So 12 is a possible common denominator, okay? So then we got 24 as our possible common denominator. That's not so good, but 12 is good. So the next thing we're going to do is we're going to divide 24 we're going to divide it by 3. All right, so we're going to divide the 24, our original common denominator, going to divide it by 3 now. Remember, we're going to divide it by 2, 3, 4, 5, etc. And so we get 8. And the question we're asking, is 8 a good common denominator? So we ask the question, is there a whole number that you can multiply 4 by a whole number and get 8? And is there a whole number that you can multiply 6 by and get 8? And the answer is yes. You can multiply 4 times 2 to get 8, but there is no number that you can multiply 6 to get 8. So this is not a potential common denominator. So we don't add it to our list. So our best least common denominator so far is still a 12. Okay? Then we'll continue on. We'll take our number, our 24, divided by 4 this time. And it divides evenly, so we can ask, is 6 a good least common denominator? So we again do our multiplications. Is there a number that I can multiply 4 by to get 6? The answer is no. No. Is there a number? Yes. But we need them both to work, so this is not a good potential least common denominator. And you can keep on going. So can we divide our original number 24 by 5? And the answer is we can't even divide it by 5. So that means 5 is not a potential least common denominator. Okay? And you can keep going. Maybe you have to go to 6 or to 7, or etc. But at some point, you realize that the lowest number that you can get to is 12. And so we just basically said that 12 and 24 are common denominators, but 12 is our least common denominator. So we took 24 and we kept dividing it, and we checked to see if those things divided. Now it might be that the original one is the only one, okay? But in this case, we could divide it by 2. And as a matter of fact, what we're doing there is we're actually removing that redundant factor, it's the same as the hard way. It's just a different way of thinking about this. Okay, so let's run through this again, just kind of the way you might do it on a scratch page. I'll do a lot of the math in my mind. So the first thing to do is find a common denominator, multiply the 4 times 6 to get 24. And then I'm just going to do a mental division. 12 is to divide by 2, 8 is divide by 3, divide by 4 is 6, and divide by 5 gives me nothing. And so now I've got to check to see, I know 24 is a least common denominator. I got to see if 12 is a least common denominator. So then I got 4 times 3 equals 12, and 6 times 2 equals 12. And so that is a common denominator. I ask myself, can I do this for 8? And the answer is no, that's not a common denominator. Can I do it for 6? Is there any number I can multiply? And the answer is no, so that's not a common denominator. So the only the least common denominator, at least of the ones these I've checked, the least common denominator is the 12. So that's pretty much how you do it. So that's it. Let me do a couple more examples. Okay. So here's another example. This is going to be 3/10 plus 1/6. Okay, and we're just going to look for the least common denominator. So the first number you do is you just take 60. And then we're going to divide it by 2. That's going to be 30. Then we're going to divide it by 3. That is going to be 60 divided by 3 is 20. And then we're going to divide it by 4. I might have to do a calculator, but that turns out to be 15. And then divided by 5. 60 divided by 5 is 12. Okay, so this is our list of potential least common denominators, starting with the one we're sure is good, but it might not be the lowest. Okay, so then what we're going to do is we're going to say, okay, what can we, 10 times what equals 30? 6 times what equals 30? Well, in this case, 10 times 3 is 30, and 6 times 5 is 30. So 30 is good. So 30 is good. 20. Well, 10 times 2 equals 20. And 6 times, oops, no, that's a fail. There's no number that I can multiply by 6 to get to 20. So 20 is not. And if I do it again, I say 10 times what equals 15, because I'm looking now at 15. The answer is there's nothing. So 15 is no good. And similarly, 12 is no good. And so by the process of elimination, the least common denominator is 30. 60 was a common denominator. 20 is not a common denominator. 15 is not, and 12 is not. But 30 is the least common denominator. So 30 is the number that goes in here. Okay? So 30 is the number that goes in there. And if we know that this number is 30, then we end up with over 30 plus over 30. And we have to multiply the top and the bottom here by 3. And we got to multiply the top and bottom here by 5. So 6 times 5 is 30. 3 times 10 is 30. 3 times 3 is 9. 1 times 5 is 5. And so we get 9 plus 5 is 14 over 30. Now this actually can be reduced, but it's not because we didn't get the least common denominator. That becomes 7 over 15. 15 couldn't have been a common denominator, but we still had to reduce the fraction. So, okay. So here's another one. 1/4 plus 2/3. So here we go. We're going to take and multiply the two numbers together. 12. That's our common denominator. Then we're going to divide that by 2. And we'll get 6. Then we're going to divide it by 3. We're going to get 4. Then we're going to divide it by 4. And get 3. So again, here are our potential least common denominators that we've got to check. We know that this is a common denominator. So the question now is, can we take 4 times something and make 6? No. So we don't have to check 3. Can we take, so this is bad. So can we take 4 times something and make 4? The answer is yes, so that's 1. Can we take 3 times something and make it be 4? The answer is no. So this one is no good. And similarly, this one's no good. So in this case, 12 is the least common denominator. We checked all these other common denominators, possible common denominators. They're not. So the least one is the 12. And so this ends up being 12 is the right number here. Okay? So to do this one, if we know that the least common denominator is 12, we're going to put it over 12 plus. So this one we're going to multiply times 3. 3 times 4 is 12. So we'll multiply this one by 4. 4. So 3 times 1 is 3. 2 times 4 is 8. And then we end up with 11 over 12. And that's the right answer. Okay? So that's that one. So you say to yourself, okay, Chuck, these have all been really nasty, right? Are really easy. Let's get a really nasty one. So here's one more real nasty one. So here's a common denominator. Now this one would be kind of tough. What are the prime factors of 21 and 6? So let's just follow the rules. The rules are, first you multiply the two numbers together. 21 times 6. You might need a calculator for that, but that ends up being 126. So 126 is a common denominator in this situation. But remember, the first thing we do is we divide it by 2, and then that ends up being 63 as a common denominator. Then we'll divide it by 3, and that will be 42, right? So 42 is 126 divided by 3, and then divided by 4, it doesn't work. You can't divide it by 4, and you can't divide it by 5. Oops. You can't divide it by 5. So our potential list of common denominators is 126, 63, or 42. So we know that this one's good, right? So now we're going to say 21 times what equals 63. Now you might have to use a calculator to get this, but look, 21 times 3 is 63. So that's good. It has potential. Now we got to check the other one. 6 times what equals 63? Well, 6 times 9 is 50. 6 times 10 is 60. And so that's not possible, right? So 6 times 10 is 60. 66 would be 6 times 11. So that's not possible. So 63 is not a good one, okay? So that's not a good one. So what about 42? 21 times what equals 42? Well, that is 2. 21 times 2 is 42. 6 times what equals 42? Well, 6 times 7 is 42. So look at that. We have a common denominator. We had a potential common denominator. 63 wasn't. 126 is. 42 is. These aren't possibilities. And so our least common denominator, at least of the ones we checked, is 42. It's the lowest of the common denominators that we've checked. Okay? So now another thing, just before I erase this, is we also have figured out in this number 2 and the number 7 what we have to multiply, top and bottom. So this one we got to multiply 2, because 21 times what equals 42? Well, we needed that number anyways, because that's the number we put here, right? And then 6 times what equals 42? Well, that's this number. 6 times 7 equals 42. So we had to figure this out anyways. So in this calculation, we can remember these numbers that correspond to the least common denominator, because that gives us what we're supposed to multiply. Now I have to clear the screen a little bit. So we're going to remember that 42 is the least common denominator, and then 2 and 7 are the numbers we're going to multiply by. So, okay, here goes the screen. Sorry. You can pause it if you want. Okay, so our least common denominator is 42, right? And to get to 42, we got to multiply the top and the bottom of this guy by 7, and we got to multiply the top and the bottom of this guy by 2. So that means 2 times 21, 42, thankfully. 6 times 7, 42, looking good. Now we do 2 times 4, which gives me 8. 1 times 7, which gives me 7. And now I can simply put the 42 over here. My bottoms are lining up, my denominators are lining up perfectly, so I simply add across the top. 8 plus 7 is 15. So my answer is 15 over 42. And 42 was my least common denominator. Okay? So, to review, the easy way is first you multiply them to get a common denominator. I've phrased that particularly. A common denominator, one of them. It's not the least one. Potentially might be the least one, but it's not necessarily the least one. Then we take that denominator, divide it repeatedly by 2, 3, 4, 5, and if it's a really big number, you might have to divide it by 6 or 7 even. and then check them. And then check. You got to check each of those numbers to see if it's still a common denominator by looking for something that you can multiply both numbers by to get to it, and then pick the lowest of the valid common denominators. So it is just pick the lowest common denominator. So that's the trick. You may have to watch this a couple of times to really get the trick. If you remember, I started this whole conversation talking about why are people so crazy about least common denominators. You know, why do they care so much about least common denominators? And I told you that I would come back to that at the end. And so the reason that math teachers and people that build math curriculums really like least common denominators is that they reinforce some really important math facts, math skills. And so you have to, prime numbers are an important math skill, important knowledge. Prime factors, it's really a good exercise of your ability to quickly divide numbers in your head to do prime factors. It makes you do a lot of division in your head, so you get real comfortable with multiplication tables and division. And there's a lot of nonlinear thinking in this kind of hard way of doing it, because you got to do things like see, 1/6 over 3/4, and then in your brain you got to sort of like, this has to sort of like nonlinearly turn into 2 times 6 in your mind, when this one nonlinear kind of turns into 2 times 2. So this is, you're breaking numbers down into these prime factors. These are your prime factors here. And so it's really a great exercise when you can do it the right way, and it's really good if you could do it the right way. The problem is, if you're getting stuck on it, you can get stuck on any of these notions: prime numbers, prime factors, not being good at division in your head, and not being good at sort of nonlinear thinking. Frankly, not being good at these 3 things generally makes nonlinear thinking pretty hard. And so there's just too many core skills. And so that's why I came up with the easy way. It's the easy way. But just because I told you the easy way doesn't mean that you shouldn't understand the hard way. The hard way is important. It's a good thing to know. And so this is my suggestion. Learn the easy way. Use the easy way until you rock with this. And you can do least common denominators in your sleep, because you need to know how. It's an important skill. You can't really add fractions, and you'll get stuck if you don't learn how to do least common denominators. And it's good, the way I do it is good practice for your multiplication tables. It doesn't require as much division. But then, once you master the easy way, then go back and learn the hard way. And once you're really sharp, and you should go explain it to somebody else, right? Go explain to somebody else how to do the easy way, then how to do the hard way, and then the real cool math thinking that you got to do is why these really are exactly the same thing. And of course the hint is, remember the 2 times 2 and the 2 times 3, and remember how we didn't add that factor the second time. The division is equivalent to that, okay? So there's your hint, okay? No more hints, because that's the end of this lecture. If you listened all the way to the end, I really appreciate it. I enjoyed making this lecture, and took a little bit of time, but I think that least common denominators are something that is really hard, and a lot of people get stuck on it, and it doesn't have to be as hard as the people make it out to be. And if I get a lot of comments, if you want to tell me things that I should lecture on in addition to least common denominators, so let me know in the comments. Thank you very much.